So, guys and girls, welcome back to another spaceexplr episode. Today on the show, we have a very special guest, as you're going to see him here in a few minutes. But first of all, let me introduce you to Trey Henderson. So, he's a graduate of Embry-Riddle Aeronautical University with experience design rocket engines and high-field plasma fusion devices. Trey is an avid landscape and astrophotographer who started his journey with astronomy about 4 years ago. And of course, you're going to find an Instagram link to see his personal journey, experience, great astrophotography pictures, which of course you have to check it out. So astro_adventurer, which of course, as I told you, is going to be in the show notes. Trey, big pleasure. Happy to connect it. And thanks for your time. Really appreciate it.
Yeah, thanks for having me on, man.
Thank you. Again, we kind of spoke before a little bit, and you just, as I mentioned, you just came back from Hawaii and, had a great experience there as well. So, and we kind of talked about it, and I wanted to take to that direction because I do get asked a lot about how you do, like, get involved in the space industry, where do you get started, and you being part of the Embry-Riddle Aeronautical University. And I think I had somebody on the show who goes to the same university. I can't remember who, but can you talk about why, first of all, have you chose to pursue this and, everything that you do in the space industry, and how people can, pursue their own personal careers or education in this field as well?
Yeah. So it's probably Will, who you had online last time, Astro Burns.
I think so.
He and I, we shoot together quite a bit, actually, when he's up in the New England area. So I mean, how to get into the space industry? It depends on what avenue you want to take to get in, right? So I went the engineering route. If you're not like a sciencey minded person, which I imagine most people that watch this podcast probably are, but if you're like really good in business or communications or whatever else, if you're good with your hands, right? If you're not like a person to design rockets or design aircraft, you can still build aircraft or rockets, right? So it's open. The field is open to everyone. You don't have to be an engineer. You don't have to be a this or a that. Our industry needs some of everyone. But the way that I got in was I pursued an aerospace engineering degree. And so I got that from an aeronautical university, Embry-Riddle. It's pretty well known in the aerospace community. Chances are, if you're not in the aerospace community, you've never heard of it, but it's a small, super specialized school. It's really well known for what it does. So I went the engineering route, and then from college, I think like most people, I just applied to internships around to different companies and finally landed one. My first one was at SpaceX, and from there, I got to do a really great tour of the aerospace industry at SpaceX, United Launch Alliance, and Blue Origin, doing kind of a whole variety of work with those companies. But yeah, I mean, you don't have to fit a mold to fit into the aerospace industry. Everybody contributes to the project. We have to sell the rockets, we have to build the rockets, we have to design the rockets. I mean, whatever you want to do, you could do in our industry.
Got you. Okay, so I mean, from a personal experience and like working with like-minded individuals, and so solving the problem, how do we go to to the moon, how do you go to the Mars? Because again, one of the biggest probably obstacles is technology, and it comes down to rocket engines, propulsion systems. But besides that, like, what would you recommend? Like, what do you see personally in the industry that it's a huge problem that has to be solved, and people should be paying attention to that, and more people should get involved in that particular kind of particular part in the industry?
I really do think reusability is a key aspect. And I'm not saying that just to toe the company, the SpaceX company line. I'm not part of SpaceX anymore, but I'm not doing that to toe the SpaceX company line. But if you get down to the fundamentals, it makes sense, right? You don't build a new car every time you drive from your house to your friend's house. You don't build a new plane every time you fly from LA to Atlanta. You don't build a new boat every time you take it across the ocean. So it's a ridiculous concept to throw away an entire launch vehicle every time you fly it, right? So reusability and getting that pace of reusability high enough and the cost of reusability low enough is going to make routine space travel just like any other travel around the world. So I really do think that that's probably the key to making space available in the near term. If you're talking longer term, that's kind of venturing into lower TLR or technology, TRL, sorry, technology readiness levels of propulsion technology, right? So, nuclear propulsion technology is quite advanced. It's just not well accepted in the community. And then you're talking about more theoretical stuff, a fusion energy drive, a fusion propulsion drive, or, something along those lines. But that's what will eventually take us to the stars. But in the near term, let's focus on reusability. Let's get rockets flying more often and more cheaply. And then once we do that, we can really try to venture deeper into space.
Mm-hmm. So, and that's great. I love it. So, what would you say when it comes to the industry? Because it's very it requires a lot of capital for somebody to start a rocket company. And there's probably just a handful of these companies. SpaceX, again, Blue Origin. Rocket Lab. And just a few that Firefly. I think the few that you can mention, that the ones that stand out, and the rest are probably go bankrupt, and didn't get to that level as a SpaceX does because of the probably multiple reasons. But what would you say, like, for just, from looking as an industry insider, and like, what is the problems that we're facing? So of course there's delays because of the technology issues. We have to, like, what's happening now with the Starship, and again, all these test flights, and we're seeing the rockets exploding all the time. There's going to be a lot of failure along the way, because a lot of the stuff that we're looking to create is not being done yet. Like, I spoke with multiple NASA engineers, and they told me the same, like, creating a moon base. It sounds very easy, when you watch a movie, but it's really difficult in real life because it's never been done before. So of course it will take time. But, from like industry perspective, like, why things cannot go faster? Again, you mentioned about nuclear propulsion, and, things are taking too long time. And part of that, of course, it's just the industry is probably not getting enough attention and capital at the same time. There's a lot of regulations from government standpoint. But what would you say that will kind of impact the rate of innovation from what you're seeing currently, that would make that drastic change in the space industry when it comes to all these propulsion systems?
Yeah, so I think one thing that hinders the space industry is the space industry is inherently risk averse. So the space industry does not like putting big bets on new technology. You have massive defense contractors which have, hordes of money, and they continue to develop the same technology that's been used since the 60s. Honestly, the 50s. They make it better incrementally, or some of the engines that are flying today are the same ones that have been flying since, God, the 60s, the 70s. I mean, they really haven't been improved that much, and that comes back to the risk averse nature of the industry, is that no one wants to take a risk. And so that's where the new startups are really coming in and taking that risk. But the problem is with a startup, I mean, like you identified, they don't have the huge sums of money that the large contractors, the large aerospace companies do, right? So, they take a risk, and a small failure is enough to end their progress. So they're in a situation where they can't have a robust R&D program like a large company could. They fail and they're over, whereas a large company could devote more money into those. Now, I'm not a business guy, so I can't say why most startups fail. I'm not saying most startups fail because they're too risky. I'm in a startup right now, and obviously before I joined a startup, right, I did my research. I was like, okay, so what are the odds of this working out? And research shows that a lot of the times it's having the wrong team, right? You need the right team of people together to make a project happen. So that's just an inherent burnout rate of startups. Is you're going to have startups that come together that have the wrong people, have the wrong skill sets, and they just kind of fail. But really, I'm super optimistic for the startup aerospace community because there's so many of them. I mean, there's the big names that you do hear a lot, but there's a ton of small names that you don't hear as much. And so seeing those small names just multiplying is really promising, because all it takes is for one of those small names turn into the next SpaceX. I mean, in 2002, SpaceX was a small name, right? So which is going to be the next SpaceX, or which is going to be the next, Blue Origin, or Rocket Lab, right?
Mm. So, and do you think it's gonna be like all these breakthrough moments that we're talking about? Like a lot of people, including myself, are excited about, occupying Mars type of scenario. So, going and exploring the exoplanets. So, do you think all the technology that's going to be driven and that will create that change is going to come from all these, as you're talking about, small startup companies, or is going to be something from private, from government agencies?
I think it's a partnership of the two. So they serve kind of different roles. Like, I think startups and these smaller companies, their position is to take technology, like earlier I mentioned the TRLs, technology readiness levels. It's to take technology that's pretty well developed already and implement that, make it cheap, make it fast, make it easy. The goal of the government, on the other hand, is to raise the TRL of other technologies, right? That's the way I think of it, at least. It's either for them to do that work or to fund that work with contractors. Like, for example, SpaceX gets some money from the government, and in return, the government gets launches, and same with the Air Force. The Air Force sends them some money, and then they get launches. And so that helps fund some of the projects there. And, that's how lots of the vehicles at SpaceX have been able to be built and, not bankrupt Elon Musk. I know he's, the richest, or like the second or third richest, depending on where Tesla stock is, man in the world. But he wasn't the richest man in the world in 2002, 2006, when Falcon 1 first flew. So yeah, it takes a lot of outside investment. And a lot of times in the aerospace industry, that does come from the government, because the government and the Air Force has big interest in having a presence in space.
Gotcha. Okay. So yeah, so with Elon Musk, I think it's just 1 in a billion or 1 in a trillion, scenario. Like just pick a number, because, like, for somebody to take all the basically, I think it has like 120 million, whatever he had left over after he sold PayPal, and he divided that money and started Tesla and started SpaceX. I mean, that's really bold bet for somebody to take.
Yep.
And go and rent an apartment and live in a rented apartment where you have all this capital poured in into startup companies, and it's 2008 and it's the worst time for, electric car maker to get started in the biggest like recession ever. So, I think, just like him, it's not going to be a lot of people. And that's what we're talking about, the startups failing, because for whatever reasons, and maybe he is part alien or part cyborg, who knows, but it helped him to thrive and to survive and to kind of lead the industry, at the same time. So I don't think there's a lot of people who are really that unique, just like him. I know there's a lot of smart people, but he has definitely some qualities that helped him to persevere and, just to drive the industry, which is really great. So again, talking about, you mentioned another topic which I thought that was very interesting, is high field plasma fusion devices, which
Mhm.
maybe for me, who never heard about something like that, to never, interfere with something like that. What is that, and how does it work, and why is this useful for us?
Yeah. So okay, so I'll start this explanation a bit more basic, because I think most people that watch this podcast are super into space and super love rockets, and probably are really well versed with that. But the people that are versed in tokamaks is a lot smaller. And I will not claim to be an expert on this at all. The physicists at our company, they are the true experts on these machines. I am just an engineer building the machine, designing and building the machine. So when I say a high field plasma fusion device, what I mean by that is primarily a tokamak is what I'm familiar with. And let's see, what is the easiest way to describe this? So a tokamak is like this Russian conjunction of toroidal chamber with magnets. If you take like the first two letters of each Russian word that says that phrase, it says tokamak, right? So it is it literally, imagine a donut, and then you have these big D-shaped magnets that go all the way around this donut, right? And where the donut is plasma. And what these magnets do is they confine the plasma and they hold it in that shape. It's called a toroid. And inside that plasma soup, basically, you have 100 million degree ions. And these charged particles are flying all throughout this soup. Specifically, they flow along the magnetic field lines of the combined magnetic field lines of the magnets that surround it. And when those 100 million degree ions slam into each other, they fuse, right? So there's a couple parameters here that make all this happen. One's the plasma pressure, so it's under high pressure. When I say high pressure, I only mean 1 or 2 atmospheres. So it's not, high pressure like most people think high pressure, but it's high plasma pressure. It's under extremely high magnetic field pressure. And then you have the kinetic energy of those particles, right? I mean, temperature is just a measure of kinetic energy. So when I say it's 100 million degrees, that's kind of like a non-physical temperature. It just means the atoms are moving super fast, right? So they slam into each other and they fuse. When they fuse, they release energy. So that's the whole concept of a tokamak, is you've got this extremely high temperature plasma that's confined by magnets. You've got that fusion process and you're releasing energy when you do so. Let's see, what did I miss in there? High field. The specific difference between high field and low field, most all tokamaks that have been built previously are low field machines, meaning they use something called low temperature superconductors, or they use copper magnets, so very old technology, and they're only able to reach a few Tesla. I think, like 8 Tesla or so is about what they can reach. Now, high field machine, on the other hand, can double that. And doesn't sound like a lot, but doubling the magnetic field has a very nonlinear response in total fusion energy output. It's actually to the 4th order. So that's 2 to the 4th is the change in fusion potential between those machines. So that's like word vomit about tokamaks. Hopefully that meant anything at all. Hopefully you got something from that. If you have specific questions, I'll try to answer those to maybe clarify.
And Trey just saw me just nodding my head like I understand what he's talking about, but it's a very interesting topic, of course, because, we do look for alternative resources for the energy. So how tokamak can be used? Can you explain what type of scenarios we're talking about where, this specific engine can be used?
Yeah, so a tokamak would be best suited as like a power plant. So imagine a nuclear power plant, or imagine a coal power plant, or any of those centralized energy generation facilities. Essentially, tear that down, build a tokamak there, right? It can be as a stand-in replacement for those kind of energy plants. Primarily we want to replace fossil fuels. So hopefully the oil and the coal, those are the kind of things that we can eliminate. And then, depending on how the public climate goes with nuclear, we can replace that as well. It can replace, wind and solar as well. But really, I think wind, solar, fusion, all those really go hand in hand. They're clean energies. They're not contributing pollution. They're not contributing any sort of damage to the ecosystem. So we're not really trying to compete with those. We're just trying to supplement those, because in the end, if we don't do something, our planet's gonna, literally catch up. Well, not literally. It's gonna figuratively catch on fire, right? So we have to stop global warming at some point. And this is one way to do that effectively, for replacing the coal and the oil and the heavy polluters. It could also be used in, think of like very large ships. How some military ships, for example, they have nuclear reactors on them that provide the propulsion energy. Mm-hmm. You could imagine a very compact tokamak that could do that down the road. As you build tokamaks smaller, the physics gets harder, so that needs more technology development. But yeah, there are applications beyond energy generation as well.
Mm-hmm, gotcha. So And again, when we're talking about those, scenarios of creating a power plants, anything that probably, has a word nuclear fusion is probably for people, it creates this kind of, ooh, is this actually safe? Remembering the 86 and the, Chernobyl disaster, like, is this, a safer approach to nuclear power? Like, with this tokamak, can you explain a little bit?
Yeah, so tokamaks, I'll address the questions that I get asked the most. Tokamaks cannot melt down. So a tokamak requires a steady input of energy to keep it running. And anybody who's heard of these machines before has probably heard the adage that you can't get out as much energy as you put in, which has been the case for the last 50, 60 years of developing these machines. We've never reached positive net fusion energy. That's why a lot of people also have heard the adage that fusion is 40 years away and always will be. We in our startup mentality like to think otherwise, and we're pretty optimistic about our timeline being much shorter. But I don't know how I ended up on that tangent. To your direct question, though, no. So it can't melt down. There's no opportunity for a Chernobyl or a Fukushima or a 3 Mile Island, whichever one that was in New York. That can't happen with a tokamak, first of all. Second of all, the long-lived radioactive waste of a nuclear power plant, like a nuclear fission plant, is not created in a fusion machine. So a fusion machine creates very short-lived radioactive material. So we're talking on the order of just a few years is the worst radioactivity level that you'll experience. Most stuff is unactivated or deactivated within weeks. So when you go to decommission a nuclear fusion plant, you've got a small subset of material that needs to be stored for perhaps 10 years at most. The rest is wait a month and then you're fine. So it's very different. Imagine Ukraine, right, where Chernobyl took place. That's still radioactive today, and that happened in the 80s. So
Gotcha. Okay. I'll take your word. I'll take your word. So I feel a little bit better about the entire tokamak situation now. So
yeah.
you mentioned that it's possible, again, going, further in the future with this, technology, it's possible to shrink the size of the tokamak, right? So are we
Mhm.
talking about, using this for the cars in the future, for electric cars? Is that possible as well?
That's certainly optimistic. I don't know if we'll ever be at the point where we have a tokamak that you can hold in your hands, or there are other fusion machines, right? There's also stellarators, there's linear pinch machines, there's reverse field machines, there's all sorts of like different configurations that you could try fusion in. They're just much lower efficiency than tokamaks, which are kind of the leading way of doing it at the moment. So I always reference tokamaks, so that's where my head lies. Yeah, I don't think we'll ever be at that point where you pop the hood of your car, your 2070 model Tesla or whatever, and it's just got a tokamak built in. I don't think that'll be the case, but hey, you never know where technology might go, right? So
Exactly, indeed. Okay, so and talking about the global scale of what's happening again with the global warming and stuff. So do you think we're at a time where it's kind of irreversible for now? Like we're so long ahead, and it's impossible for us to turn it back, and that's why we look at the Mars as kind of backup scenario because there is no possible way to turn it back. Or do you think that through again the government involvement and saying, okay, we should go through these different again different energy sources, it's still possible to save the planet?
yeah, it's hard to say because we're like right in the middle of it at the moment. When you're trying to calculate the slope of a curve and all you've got are points and you're trying to interpolate between those points, right? Very slight differences in assumptions can make huge differences in the final outcome, right? When I look at the curve of global warming and our production of greenhouse gases, I think we're at the point where we need to be acting either today, or we need to also be planning active ways of lowering the temperature of Earth in the future, right? We can go along the assumption that all is fine and we can see what happens, right? If you take the most conservative case of those extrapolations and say, well, this one analysis says we'll be fine. We don't have to do anything for the next 50 years and we'll be fine. Well, you can do that. And then there's the slight chance you're right. There's the major chance you're wrong. So I like to say that, yeah, we need to take action today. And we also need to have backup plans for, if we stopped all carbon production today, and then how are we going to start sequestering that carbon? How are we going to start cooling the atmosphere again? How are we going to start, replanting what we've deforested? How are we going to start, making good with the damage we've done so far and trying to even reverse that?
Exactly. I mean, that's a big topic. Like a lot of people that I talk about, they, especially a few people that I had previously on a show, they, because sometimes you do forget about that this is happening, because we have multiple things happen, in a personal life, and as everybody who's listening or watching do. But it's something not to be taken lightly. It's not something that oh, it's a science fiction. This is might happen in another 1,000 years. We should forget about it. I mean, it's a problem, and we have to look at it and try to solve it. And of course, it's great that we have, again, just like Elon Musk with his Tesla, like he's showing an example. And I think a lot of big companies, Ford, Volkswagen, they're creating now electric cars at the same time. So this is great. We see the change. But do you believe that the change is happening right now? Is this enough to reverse it, or we should put more wood on the fire?
I think we should definitely put more wood on the fire. I think more people need to be pitching in, and more money needs to be devoted to this kind of research. It's promising to see things like photovoltaic cells, solar cells, have come down in cost 10x over the last 10 years, right? So seeing solar panels being that much cheaper in just 10 years, huge benefit to the end consumer, right? Because no one could afford solar cells in 2005, right? No houses, it would have been insane to cover your roof and at that point in time. I mean, some people I'm sure did, but now though they're becoming more and more common. If you have something drop by a factor of 10 in cost, that's major, right? That's a big deal for the end consumer, and it has more adoption. So we need more people to bring the cost down of solar panels. We need the cost and the prevalence of wind energy to increase. We really need to be exploring all these avenues. And one thing that's really exciting about the fusion industry specifically is it feels a little bit like the early age of the aerospace startups. There's a few competitors in the market right now, and it's growing. So I mean, there's us, there's General Fusion, which I believe is up in Canada. There's Tokamak Energy, which is in the UK. There's a lot of little startups that are coming out, and we're very early in the stages of development of our machines, but it's cool to see all these different companies trying these different methods, because I think that's what we need. We need people probing every avenue to see, okay, which is the right path, and having that kind of exploration is what we need. We just need more of it. Hopefully, Biden recently mentioned, I think it was a $2 or $3 trillion infrastructure plan. Some of that includes a few $100 million or maybe $1 billion. I'm not sure. Oh, sorry, no, that was an order of magnitude off. I think it was a few $100 billion that was dedicated to green energy. So that's really promising to see, as long as the money is going to something. I'm not saying it has to be fusion. I love fusion. I think it's going to be fusion, but as long as it's going to something, right? That's what we need today.
Exactly. And do you think, or do you believe that, is there is a way to get public more on board of this, entire idea of going green and using different, because, I'm sure there's a lot of people that right now are watching or listening to this episode and thinking about, okay, Tesla, it sounds and looks like a great car, but paying 100K for that, and it's electric. I don't know if I would like that, because again, I do understand, as I mentioned, there are different competitors who offer different price points, and probably you can buy a Chinese car, neither that I do recommend to buy it, probably for half of the price or less than that, because of course it drops in quality as well. but I'm sure the price will get lower. But still, there will be people who want to buy this, 7-liter Mustang. They want to drive, they want to hear the engine. So how we can get public on board saying, no, look, this is driving quiet but still fast. It's
Yeah.
better than driving the car that you have now.
Yeah. I really honestly think the key is just to make it look and feel cool, right? I mean, it sounds dumb, but just give it a minute of thought, right? And that's what Elon does so damn well,
Yep.
is he makes everything look cool. It feels cool doing it. Like, you want to be the person that owns a Tesla because you look at a Tesla and you're like, damn, that's a cool car, right? And that's what it takes, I think. I mean, like, the Prius is a great car. It gets good mileage, but there was also like a lot of people that hated on the Prius because of the way it looked, right? It didn't have a lot of power. It didn't, it wasn't the sexiest or the sleekest car ever, right? So you had camps. You had the I'm a green energy nerd camp, or I like my, Mustang, right? But you have a Tesla now, which merges those two, where the green energy nerd is no longer just a nerd. They're like the cool guy with the car. And then also the Mustang guy is like, damn, I like that car, right? So we need to make that happen with all things related to green energy and elimination of carbon, plants, and all the pollution sources we have around the world. So it's something we are considering with our device, at my company, is, how do we make it look cool? How do we get people interested in this technology? And it doesn't just look like another building full of, junk and sciencey equipment that you can't tell what it is, right? You have to make it accessible to the public.
Got it. Got it. And that's a great perspective. I love it. Okay, so once you continue to make it cool and environment friendly is kind of the key for the car making industry. So that's great. So another part of getting people on board is you just came back from Hawaii from the trip. You mentioned before you like the landscaping and of course astrophotography. And like myself, I see and I talk with a lot of astrophotographers who are just getting started. And like a lot of people tell me, like, you won't believe like all these high-end manufacturers, all the equipment that you're buying for for your astrophotography hobby is like the shelves are empty most of the time right now. And of course it's probably manufacturing is kind of a problem where with shipping with the COVID, but it's probably the second thing because there's so many people getting started in this in this field, which is really great. So can you explain, like, for the people, why it could be probably a good option for them just to get involved with the space industry? And second of all, kind of understand, like, why should we go, probably the green route? Because look, we live in this universe and it's beautiful. We need to take care of it, everything that we got here as well.
Yeah. So I mean, why you should get interested and involved in the space industry? I mean, there's a million reasons why, right? I think that reason should always come from inside, like from your own personal like want. But for me, I don't know. I mean, my personal want was we're like literally a speck of dust in the ocean of the universe, right? So when you look at that and you think how much there is to explore and how little of it that we've explored, yeah, I mean, I just want to go and explore and find out what else is out there, right? I think, maybe we're a little early for exploring the deep reaches of the universe physically. Like, of course, we can do it with our telescopes, but can you do that, with a rocket? Not quite yet, but it takes, millions of more people like me to join the industry with that same want, right? To develop the new engines or develop the new rockets or develop the new, warp drives or whatever, right? To get us deeper in space. And it, many hands make light work. So it takes everybody to pitch in. So that's why I joined. I don't know, other people, you could have financial incentives. It's like, hey, there's asteroids out there. They have resources on them. Let's go get them, right? You could have just general science ambitions, like sending probes to other planets. I mean, there's so much cool stuff that you can do in space, and we've done so little of it so far.
Gotcha. So, of course, I want to talk about astrophotography, but when I come back to the point, as I mentioned, people joining the space industry for different reasons, different incentives. And would you believe or would you think that space should be explore just for that one reason, because it's cool and because that's what we do. We're probably natural or explorers. We go to the different parts of the world. We like to do that stuff, right? We're naturally that. Or
Yeah.
do you think we should pursue this from a business perspective and we should go and mine the asteroids? Or do you think it should be both or one? Like, what's your perspective? What's the right way to treat the space and the universe?
Yeah, I mean, do we all consider it our domain, and do we take it for ourselves, or are we just there to visit and
Hmm.
and
Yeah.
explore? It's a good question. I I try to think what harm is done if we do something. And if you capture an asteroid and you bring it back, you mine it, or you mine it in situ, right? What harm is then done to the universe or to other things that may need it? When I say things, colloquially aliens, right? I mean, the aliens don't need the asteroids in our asteroid belt, right? We don't have any evidence of microbes being on these asteroids, so it's not like we're disturbing any other creatures or energies out there. So in my mind, I'm not a businessy type of person. I'm not a, hey, let's go strip all the diamonds out of Africa or whatever to get all of our money. I'm not that kind of person. I try to balance good and bad where I can, and I think it's fine. I mean, it's for us as a civilization. That's a rich source of resources, and if we're not harming anyone or anything in the course of doing it, sure, mine it. And I think having financial incentives really plays well with the free enterprise. If we say, here's the launch vehicles to get to these asteroids, now you have a way to get there. You just need to develop the mining systems and the harvesters and things like that, and you can have billions or trillions of dollars of whatever precious metals are on these asteroids. Go get it, right? That's the incentive. A lot of people work on the incentive of money. So if you tell them, hey, there's money to be made, then they'll go get that money. It's like, the gold rushes, right? If we say the new gold rush is in the asteroid belt, then we'll have a huge explosion in technology development, which is then good for us, right? Because then we take that technology and we use it for further space exploration as well, not just space exploitation.
Yeah, we are weird creatures, I think, because we do like those things that you mentioned. We like getting paid dollars, euros, yens, pounds, whatever country you live in. Diamonds, like ladies. This is kind of the best friend. There's so many songs. Gold. It's been a currency. It's been money for a very long time. And like we find these things, we're attracted to these things, and it's part of probably our nature, or just going back centuries behind. So it's very interesting because I've seen this movie before. I can't remember the name of the movie, but it was quite bad. But it's just one line from that movie stood out because I remember this girl. They lived basically in a spaceship. It's like they don't have a proper. I think they lived on a Jupiter. They found a way to go through all the clouds, everything, and there was actually a bottom, which was very cool to see, but it was very tough to get in there. And I remember they were just flying in the ships, speed of light, huge. And I remember they found this resource, which humanity was the resource for them. Basically, they extracted some sort of a like water-looking material from humans, and they went and like bathed in them. It's like water. If you imagine that, is basically there's a bath, and I remember this lady walking in, and she kind of looks a little bit old. She walks in, she comes back, and she looks younger.
Mhm.
And the line that they said, she was like, "Look, the most expensive commodity in the universe is time." And I was like, whoa, that's deep right there, because we're chasing all these things like, gold, diamonds, money, and that's for us is important. Where I think the most expensive commodity is definitely a time. If we can even name it commodity, because we have nothing else. We're talking about scenarios of flying to Mars, or living in different exoplanets, because the sun is going to capture the earth after billions of years, and it will be not habitable anymore. So we're talking about the time, and we have 4 billion plus years. So And do you believe that there could be something out there, first of all, that looks at the universe from a different angle, different perspective, kind of a little bit more advanced? Or do you think we're personally just alone in here and we're making all these decisions and we're going through this time just ourselves? There's nothing else.
Yeah. I mean, I think it's just a numbers game. If you look at the number of stars and planets out there, and if you can look at that many opportunities for life and say, nope, we're the only one. I think that's an ignorant way to look at statistics. I didn't get a statistics degree, so maybe a statistician would disagree, but I think most of them would agree with me that if you look at that, it's pretty evident that we're not the only ones. Now, whether we're the most advanced ones in the universe or not, that's a good question. I think it's fair to say that there's no, all-knowing species in the universe, because if so, they would know that we exist and they probably would have contacted us, or maybe they know not to contact us because we're trouble instead. So I don't know. Who knows what is out there? But is there other life, simple or advanced? I would say yes to that answer.
Got you. Okay, so yeah, just looking by the famous Drake equation, or
Mhm.
something like that, or just people have, of course, different opinions on that. There's a lot of documentaries that we can go and watch on YouTube or Netflix or something related to aliens and aliens visiting us, and you can buy that, you can believe that. You don't have to, because again, there is no proof like that. Okay, this is something out there, and but maybe some people can tell different. But going further in the future, do you think about, as you talked before, getting incentivized? How do you think the future for the humanity is going to look like? Were we going to be living on Mars, living on different planets? How people should be incentivized? Do you think it's going to be same dollars, euros, diamonds, gold, or it should be a free society? How do you think everything is going to come out?
Yeah, I think a lot of that comes to just human psychology and our biology, I guess. If you think back like 2,000 years and then think to today, and the problems that humanity has are mostly tied to psychology, right? I mean, we have our vices, we have our addictions, we have this and that. Will we ever get to the point where we're a society that doesn't care about money, and there's not bad stuff that also happens? I don't think we're ever going to reach a utopia. I like the way that I like to think about space is, I'm sure everybody here has watched the series The Expanse, right? If you look at it, it portrays a future society where we've colonized the planets of the solar system, but we still have war, we still have addiction, we still have drugs, we still have money, people that are very motivated by money. But you also have the amazing technological advancements that have made the world better, right? And I think that's probably the way it's going to go. Now, would I like to see a utopia where none of the bad stuff exists? Of course, right? I think the motivation of money just leads to a lot of corruption and problems. But it's pretty deep in our DNA, and human evolution is not on the scale of the rate that we're evolving technology, right? We're essentially still the same monkeys that we were when we found the rocks and the sticks.
Sure. Yeah.
So yeah.
That's still a long way to go. But part of having the technology, I know it's going to benefit, society is going to benefit people here on the planet tenfold, hundredfold, because again, it's been proven. If you're going to go on JPL website and if you're going to look up the list of innovation and technology that came through space exploration, I mean, there's a lot of things that we take for granted these days. And that came through space exploration. Again, having all these, missions, Apollo missions, space shuttle. So it's great. I mean, the amounts of innovation that will come through that. Again, the big problem, and I remember another movie that I didn't watch it, but I remember my wife watched it. It's I think it was either Korean or Chinese movie. A lot of effects, and and they were actually working as trash, if we can call them trash collectors of broken satellites in the orbit. And
Mhm.
that's what they did. They get paid money for that, collecting like trash, those broken satellites, which again, we're not far from that, because this is already happening. We have companies who are actually collecting the debris in the lower orbit. So, and do you think it's going to become, again, now from space photographer, kind of lens, do you believe that's already a big problem, or do you think it's going to become a huge problem in the future?
You mean like Starlink, for example? Lots of people like to complain about Starlink.
Oh yeah, there's more besides the Starlink. There's other smaller companies, but yeah.
Yeah, of course. I mentioned Starlink because everybody likes to complain about Starlink, and it's funny because I had a little hand in that, but when I was back at DX, but um, I don't know. As an astro imager, I really think the concerns are overblown. I mean, maybe I'm not seeing the big picture. Maybe I'm not imagining what the sky is going to look like when the Starlink constellation is complete and then all the other constellations are complete. Um, but I mean, that's what rejection methods are for. When you integrate your image, you have rejection methods for getting rid of outliers. Sure, if your satellite trails are on the exact same pixel of every frame, then you're not going to get rid of them. So you're right. Yeah, it's going to be a problem. But even when you shoot at busy points of the sky, like, I mean, I'm sure a lot of people have shot Orion. There's a ton of satellites that cross right through Orion, so it's a pain in the ass to remove them. But if you just set your rejection, aggressively enough, I've never had an issue with it. I don't think Starlink is going to be that big of a deal either. It so far, I see lots of angry posts online where people are like, "Oh, look at this Starlink train," and then it's like five little dots and it goes across the sky and then they disappear. It's like, okay, you know, I don't know. I personally think it's well overblown. But to the astrophotographers' credit who have been complaining, I am a little upset that these companies aren't taking a little bit more uh, effort to reduce the albedo of the satellites. So the satellites are still very reflective, even after SpaceX has publicly said, this was after I left, so this is all public knowledge, that they darkened the satellites. Even the most recent trains of satellites still look to be quite reflective. So yeah, I think I would like to see more effort on the launch companies or the satellite development companies' side to reduce the albedo of the satellites, make sure they're less reflective. Because yeah, it'll be annoying, but it's not going to end us as hobbyists. I think where it might cause problems is when we're talking about ground-based science, right? If they have very specific measurements they're trying to take, and one of those satellites go right through, an image or a measurement that they're trying to take, that could cause problems. I can't speak on their behalf because I really don't know enough about that side, but as hobbyists, we can get over it. I don't think it's going to kill us.
Got you. Okay, because the constellation of five satellites, it will become of 10, of 15, and there's going to be
Mhm.
not only the Starlink, because again, we're talking about lowering the price of entry, because as I mentioned, through reusability, so that means more companies, more private companies, government agencies can launch satellites more often and many more satellites. So,
Yeah.
and again, if we're going to do a little bit of research, probably going to find thousands of satellites that are probably being launched this year. So
Yes.
there's the number is big, and as you mentioned, of course there's softwares that can help you to solve these problems. But when we're talking about the ground-based observatories, like the one that is being built right now in Atacama, I think it's going to be extremely large telescope. I think that's the name, kind of the biggest observatory in the world. It's kind of a shame because we're putting this infrastructure there to do really important job, and we're talking about okay, having an internet is still an important job because it's a big percent of population who don't have access to the internet globally. So it's definitely a problem, but the thing is, I don't know, do we need that many satellites and that many companies to get involved in this industry? But that's another question.
Yeah, on that topic, just to keep this one going. Yeah, it depends on what time scale we're looking at. When people ask, is this going to be a problem? It's like, well, I mean, do you mean in our lifetime or do you mean 200 years from now? Right? If we're talking, a couple hundred years from now, this could viably be the next, light pollution, right? It just starts growing and growing and growing, and then it gets worse and worse and worse, and then eventually, we may be closed out. But in our lifetime, I don't think so. I mean, I'm 27. I've got, maybe 50 more years of life and imaging in me, right? And at that point, I don't care what's happening. I mean, I do, but my body's not going to care, right? I'm not going to be out shooting. Um, so I don't think we are going to see the end of amateur astrophotography. Um, the numbers are a bit crazy when you look at how many are going to be launched. So yeah, admittedly right now it's 5 or 10 satellites in a little train, and in the future it would be 100, right, instead of just 5 or 10. But I think it goes back to what I said earlier of what is doing the most good is bringing global internet to all points on Earth more good than, I know this is heresy to say in an astrophotography podcast, is that more good than us taking just pretty pictures, right? I love my pretty pictures. I have one here, I have one hanging up here. I love going out and shooting. I have gear under my bed, I have gear in my car. I'm going out to shoot tonight. I love this hobby to death. But when you actually question it, is it more important for you to take pretty pictures, or is it more important for people around the world to have internet where you're literally saving lives by doing that? I don't know. That it's very hard. Well, I don't think that's a very hard question to answer, but it's very hard to take your personal bias out of that and really think of it objectively. But when it comes back to the science field, yeah, that's a problem. How are we going to handle it for scientists, right? That's what we have to consider. And maybe that's some sort of communication that needs to happen between the scientists and the aerospace companies, right? If you have particular zones of the sky which are just no fly zones, right? No fly orbital zones, right? You do not fly a spacecraft through this area. Perhaps that's something that can be built up. It still limits ground-based capability, but it does allow for some sort of science with the right compromise. I don't know. That's a complex question.
Yeah, and I had previous guests. If you guys want to look for that, it's with Juan Puerta. He does a lot of space debris talks online, and he runs that part of figuring things out, the way to implement the systems. And of course, he talked about creating some sort of an infrastructure or some sort of a traffic control for satellites and the constellations, which of course it sounds like a lot of work, because we're talking about it's not only US who are launching satellites in orbit. We're talking about different companies, different countries, and how do you come together with their agreement? Okay, guys, so you should take care of that part and that. It's very hard to regulate that stuff. But I mean, the government has to be involved at some point, and they have to come to some sort of agreement. How do we go about these situations where the satellites collide and like you have debris? Because we had multiple close calls with the ISS. You probably heard this year, where they went in the Soyuz just in case the debris is going to hit the ISS, which it sounds like a big deal, and I think it happened like almost 4 times. So it is a big deal right now, and it's going to become an even bigger problem in the future. So talking about that, again, astrophotography, great topic, love it. Again, as we talked before, people are struggling with buying that equipment, which again is a good sign, unless you want to upgrade it. It's going to be a problem. Like, what would you say for the people who are thinking about, okay, astrophotography, what is that, and how can I get started in this, in this thing?
Yeah. What your question, what is astrophotography? Astrophotography is a lot of pain and cold nights and anger, but it's also a lot of reward and excitement and fun and just awesome. I mean, it is probably my biggest hobby. I've obviously, that's my picture, and I've got others around and stuff. And so, I mean, if you check out my Instagram, you'll see those. I love it to death. I mean, that's what it is. It's a fun adventure. It's a great way to connect with space. Like, seeing the images come down on your DSLR, on your special astro camera, that is an amazing connection. And an eyepiece as well. I mean, even if you're not into photography, right? Just putting an eyepiece in a telescope and seeing, the rings of Saturn. I know I've heard everybody say that. Like, the first time I saw the rings of Saturn, I was like, yeah, whatever. That's the most, cliche thing ever. And then I saw the rings of Saturn for the first time through a telescope. And I was like, damn, that is awesome. That's cool. And it doesn't matter who you are. I think that's always cool. So it's like, I don't know. It's just you can't disprove that. It's just truth that there's something out there, and it is just, I don't know. It's a cool connection. And getting into photography, then you start to see things that the naked eye can't see. I mean, you can't look through a telescope and see the extended nebulosity of some of these nebula that are up in the sky. You can't see the outer dust lanes of Andromeda through a telescope. Sure, you'll get, the core, you'll get the bright bit hits, which is really exciting to see. But when you put a camera on there and you take hours of exposure time, you put all that together, and then you get all the structure and color and just incredible detail, right? That is what blows me away every time I point at a new target.
So gotcha. So how do you get that image? Again, what you're seeing behind you right now, I mean, it's phenomenal, beautiful image. Like, of course, you can find more of these images on Trey's Instagram, which of course is in the show notes. So how do you go about buying an equipment? Because I'm pretty sure you have a good connection with a lot of people, like a few that recommended here before, Will, as well. Like, how do you go about making that decision? First of all, what type of equipment to buy? Do you even need equipment? Maybe I can do like a lot, photography, just like with DSLR camera, or you mentioned astro camera. So that means, do I need to upgrade? Like for the ones who are listening or watching, like, do I need to upgrade my camera? Is that going to mess up my daily usage? Like, how do you go about just overall just buying equipment, and like, what do you need at the price points?
Yeah, so that's a really good question. I'll explain how I got started because I think I got started in a pretty easy way. I was fortunate because I was also really interested in landscape photography. So I already had a DSLR. I had a 5D Mark III, and I already had a slew of different lenses. The most notable one for astrophotography is I had a 150 to 600 millimeter zoom lens. So it all kind of clicked to me when I was looking at my 600 millimeter lens and I was looking at telescopes, and I realized that refractor telescopes, like a medium small size refractor telescope, is about the same focal length. And I was like, what's special about a telescope then? And I started Googling it, and like I think I ended up on Reddit, and they were like, yeah, no, you can just use camera lenses for this. And I was like, what? I mean, it was insane. I realized that I had everything I needed. I had a miniature telescope. I had a camera. All I needed was some way to track the stars. Sure, I could put it on my tripod. I could take a 1 second exposure, over and over and over again. I did that. I played with it. I didn't really get any great results. Like, if you look at Nico Carver, I think he does some incredible stuff with untracked images. And I see his stuff, and I'm like, wow, that's incredible. Actually, I might be going to image with Nico later tonight, so that'll be fun. And yeah, I was never that great at all with untracked images, and I've seen some really good untracked images from other people as well. So yeah, I did go the route though of getting a tracking mount. So I got an AVX, a Celestron AVX. It's like $800 or something, and it was okay. It will get you started in the hobby. I think it was plenty to get me started. I threw on my 5D and my 600 millimeter lens. Of course, the first target I ever shot was Orion. It was an awful photo, but I was blown away. I was hooked immediately. When I saw that image come down and I saw like the blues and the purples and the reds and the trapezium and all, I was like, all right, this is a new problem for me because I'm going to be spending all my money here. So I shot that. I shot Andromeda. I shot all the beginner targets. And that was with gear that I already had, plus a tracking mount. And nowadays, there's a lot of small trackers. So you can get trackers for half what I just said. Rather than spending $800 on an AVX, you could spend $400 or $300, whatever they run nowadays, and get like a little sky guider or something, right? So those are great ways to get into it. You don't need 600 millimeter either. I mean, if you've got a crop frame camera, that helps a lot because it already gives you an extra zoom. And throw that on a 2 or 3 400 millimeter lens, and you'll be able to get some really great deep sky images. If you don't have 2 or 3 or 400 millimeter, throw it on 50 or 100 and shoot the Milky Way. I mean, you can get great images no matter what gear you've got. It's just each piece of gear will give you a different type of image, right? So yeah, I mean, I went from there. After that, I upgraded my telescope. And then I upgraded my camera first because I wanted to get into narrowband. Then I realized just how much my camera lens was limiting me. So then I upgraded my camera lens, and then, I basically did it all backwards. Everyone says, put your money into the mount. And I was like, nah, that's stupid. Don't do that. So I bought the mount last, which yes, was a bad idea, but upgrade your mount. My stars were definitely they looked like little pieces of rice because they were so elongated from where my AVX would not track that great. upgraded the mount, bought a couple more telescopes, and have just kind of been exploring since.
Gotcha. So what do we recommend when it comes to buying a mount? There's a lot of people, including like yourself, said, okay, from the get-go, get a decent solid mount that you can build on. So any particular brands and models you recommend?
Yeah, so from the get-go, I don't know if I would really recommend somebody go top line and get something really nice. So today I have an Ioptron Sim 60. I love that mount to death. It never fails me. It is an amazing mount. I would recommend it to absolutely anybody. Even, I look at people that spend, $15,000 or whatever on a whatever they're called, Mach 2, or like the super crazy mounts, and I'm like, man, I don't know what you're getting other than maybe some cool anodization or, some cool engraving or whatever on your mount, but mine does the job, man. And I only spent, $2,000 for it. So then plus the tri-pier, which was another like $800, but that's beside the point. Yeah, so I would say to start, get something cheap, because you don't know if you're really gonna love the hobby. I know I fell in love with it immediately. So for me, yeah, I should have just went off the deep end on day one. But not everybody is. Some people, I've known a few people that buy all this nice gear and they shoot with it a couple times and they realize they hate it, and then they're either downsizing or they're selling it all. And I don't want anybody to be in that situation where you're holding the bag on, if you want a top of the line setup, it could be $10,000 or more for all your gear. Like, don't get stuck holding the bag on all that gear. Start out with something small. It's easier to use and it's more fun anyway, because you're not carrying around 100+ pounds of gear, and you're not, a slave to your equipment, right? You're out exploring, and I think that's the fun part. And when you grow your gear at the same rate that you grow your experience, that's like the process of exploring. And I think that's the way to go. Start small, work your way up. And then, yeah, once you get to the point where you're comfortable, get a Sim 60. That's a sweet mount. I love my mount to death.
Here you go. Got you. So that's a really great advice, because, as I said, it could be a pricey for somebody to get involved with astrophotography. We can go from a couple $100 for hundred thousands of dollars for the mount and for the telescope itself. But just getting started in this hobby and seeing, basically testing the water and seeing, okay, do you want to last it? It's something maybe that you want to do once in a while, and buying a really expensive equipment doesn't make sense for you. Again, another guest, Michael Wilson. I don't know exactly the number of episodes, but for you guys, go and check it out. And I know recently Michael also, he uploads a lot of the phone. I think he has a iPhone 11 Pro or something like that. Basically, just a lot of people do have it, just with the iPhone, or you can do with Android. I'm pretty sure Samsung has decent cameras that you can do a little bit of a Milky Way, or probably capture a few, stars, or, maybe Orion Nebula, who knows? But, you can do a lot of that just with a phone. Like, you don't have to go and even buy a telescope, or if you have a camera, as I said, that laying, around at your house, go and work and test the waters with that before you go and buy an equipment. How do you go about making a decision what to pick when it comes to the objects? Because I know, like, on Instagram, you're a fan of nebulas. Again, we see the Crescent Nebula in the background. Yeah. So how do you pick? Because there is a lot of different solar, planetary, nebula, galaxy. Like, how do you pick what's the good thing for you to shoot when it comes to the objects?
Yeah, so that's a good point. You have very different requirements depending on what you're shooting. So if you're shooting nebula, you need a different telescope, a different setup than if you're shooting planets, right? You're probably not going to get a great image from the same gear of both those targets. Very different. Same with solar. Planetary nebula are also very different than big diffuse nebula like this. So like you said, I like nebula, primarily the big ones. The way I like to describe it is the ones that fill the frame, right? I don't want like this tiny little nebula in a sea of black and dots, right? I like the nebula that when you crop the frame, there's color, there's structure, there's detail edge to edge. That's just my personal preference. Not everybody likes that. But if that's what you like, then the way that I pick my gear is I use a few tools. So I have Sky Safari on my computer, which helps kind of visualize what the field of view is. I also use this website, and I've never heard anybody else reference it, but I love it. It's called Telescopius. It's like a really weird name for a website, but Telescopius.com is this website that I use. And that's how I plan all my objects. I do use SkySpar to find out like where the moon is and all that kind of stuff, and like angular distances and stuff. But for framing and for target planning, I use Telescopius. It will, given like a telescope focal length and a camera sensor parameters input, it will give you an idea of what your framing is going to look like on a target. And I will play around with that. And so if I'm looking to buy new gear specifically, I find a handful of targets. I try to think about what targets I have coming up and what I want to shoot. And I usually plan that out 1 to 2 years in advance. So like I have a list of targets that I have planned for certain months and certain times. So I'll be like, okay, well, here's some targets I want to slot into the schedule. What gear kind of fits that best? And I look at it with my equipment, and it's like, okay, well, can I mosaic this to get a bigger field of view? Can I prop this in to get a smaller field of view? Like, what's reasonable? If you've got a 400 millimeter, if you've got a 400 millimeter focal length telescope, so like an 80 millimeter refractor or something, and you've got that on a 1600, which is a kind of common setup, or DSLR for maybe the super beginners, you're probably not going to shoot the Crab Nebula. It's a very tiny nebula, right? So you start looking at something like that and you're like, man, okay, so I need either smaller pixels or I need a bigger telescope, bigger focal length, more focal length. And I think the most helpful thing to think of is don't think in field of view so much, think in pixel scale. Pixel scale is what matters. If you've got a very small field of view, but your pixels are football fields, right? You're still not picking up any resolution. So if you've got an SCT, so you've got a 2000 millimeter focal length, and then you've got a camera with like 15 micron pixels, right? You're undoing a lot of the work you did by using 2000 millimeter focal length. So yeah, it's a combination of the two. And there's an equation out there to calculate pixel scale. I don't know if maybe that's something you can link to in the show notes. I think that would be super helpful for people as a calculator on that, because I think me just rattling off the equation isn't going to be very helpful. But that is useful, and it depends on what you're shooting. So I try to keep my pixel scale around 1.0. That's like a golden spot so that you avoid oversampling the seeing, and at the same time, you're optimizing your resolution. Anything below 1.0, you're risking seeing, kind of ruining your images. Anything above 1.0, you're not critically sampling your image. So that's kind of my target.
Got you. Okay, and how do you go about, because like probably the 60% is post editing, processing, stacking images. So can you talk about that part of astrophotography, and what do you use again for stacking images, for post processing, and what would you recommend for the beginners also?
Yeah, so I started. Where did I start? What did I actually start out with? I remember when I first got into this hobby, there were like all these different capture tools. There were all these different processing tools, and they still exist. There's still lots of them. And I just remember like trying every one of them. I'd like download a trial of every one of them, give them all a shot, and I'll be like, no, I hate this one. This one doesn't make sense. Where are all the controls for this one? I don't understand this. This one's pretty good. And so that's how I kind of down selected. And so pretty much out of the gate, I ended up with Sequence Generator Pro as my capture tool. And then I ended up with PixInsight as my editing tool. And those are also kind of like the front runners anyway, if I had to say, for paid premium kind of software. I know Nina is a really popular free tool, so that's a great competitor to Sequence Generator Pro. Nina, I think, is totally free, so really good for beginners, and I think it has all the functionality, or maybe just about all the functionality of SGP, Sequence Generator Pro. Yeah, check that out if you're new. As for editing, I kind of skipped the Photoshop stage and went straight to PixInsight. So for a beginner, try Photoshop first, maybe. I don't know. It's hard for me to recommend it because I haven't used it for astro imaging, but I know lots of people use it very successfully for their astro imaging. You can get a subscription for Photoshop for like 10 or 20 bucks a month. It's super cheap. And then if you're really into the hobby, definitely get PixInsight. The learning curve is admittedly a pain in the ass. It sucks learning it. But once you can use it, man, it's extremely powerful. A couple things I've learned really recently that have allowed me to like seriously step up my imaging game though. And I think I've heard a few other people mention this before in your podcast. The only way I was able to print it that large is by using AI. So I use the Topaz suite of AI tools. So that image was AI denoised and then AI gigapixel. That's about a 300 megapixel image that was printed on that canvas. Because I did not want to be able to put my nose up to the canvas and see pixels, right? I wanted detail and I wanted clarity all the way, in as deep into that image as you wanted to look. So yeah, I would say if you have good data, I want to underscore that your data needs to be good first. If you're trying to use an AI on poor data, it's probably just going to make it worse. But once you've reached the point that you think your data is pretty high quality, run it through one of those AI tools. I think they offer a trial as well, and see what it gives you. If it's making your images better, then use it. My images have easily gotten tenfold better once I've used that, because I can push it further. It is glassy clean. There's no noise in it. And with the artificial intelligence sharpening tools, it feels like it reverses seeing almost. With that said, a caveat is if you're a true to lifer, if you do not like your processing to be heavy-handed, don't use AI, right? You're creating information that wasn't there. That AI is taking your image, it's looking into the image, and it is making what it thinks is structure, which might not be true structure, right? So depends on where your ethics fall, whether or not you're okay with that. And for me, my goal is to make the prettiest images that I can make. And these are the images that I'm happy making. And so I think it's a great tool to use.
Gotcha. So on an AI note, like, do you believe or do you see anything, coming up or maybe that is missing for astrophotography community that maybe, startup companies or established companies should make? Because I'm pretty sure there's a lot of the AI based, softwares that, big observatories or universities are using to, to work on data, to collect data, to make the calculations. So do you think that, like AI should be used more in astrophotography, and how can that be applied, and, which parts?
Yeah. Do I think it should be used more in astrophotography? Absolutely. I think it's great. Again, I think it depends on where your ethics are, right? If you think it's bad, then don't use it yourself. But I think it's great. It makes for better images. Where there could be advancements, I'm really not an expert in AI, so I can't say what the capabilities are. I'm one of those people, like, I hear about all the cool AI news and I'm like, oh, that's neat. Like we're almost at the singularity. And I say that and I'm like, I don't even know what the singularity is. It's just like, I just feel like it's where everything is an AI, right? But yeah, seeing things like StarNet, which allows me to remove the stars, process my nebulosity different, AI denoise, which takes out all the noise, AI sharpening, which adds all the extra structure, gigapixel, which is the trade name that Topaz uses, is just an artificial intelligence rescaling tool. I think all those have led to making better astro images. I think the one thing I would really like, because I've been having a lot of collimation issues lately with my Newtonian telescope, is the stars in my corners are obviously a little elongated, or they've got coma flares. I don't know, an AI that would look at stars and recircularize them, that'd be pretty sweet. So if you're like near collimation but you're not on collimation, so you're near enough that it's not going to hurt your nebulosity, but you're just far enough out that your stars are now getting wonky, I don't know, that'd be cool. That seems like something easy to do, but I don't know a damn thing about AI. So
Yeah, probably, I'm pretty sure there's some companies who are working on that, or maybe not, or maybe they will be working on this problem now after this episode. They will be like, oh, that's an idea. Okay, here we go. Let's
yeah,
start working on that. And do you believe that, again, a lot of the 3D printing is now being used in, space industry and space engineering, 3D printed rockets. So do you think it should be applied in astrophotography? We're talking about the 3D printed, telescopes or equipment?
yeah, for sure. So I have a 3D printer myself. It is my favorite tool that I use for my telescope. I bought it never intending to print stuff for my telescope. It was just going to be, it was my quarantine toy. It was what I was going to play with during quarantine. And the quarantine has now been a year, so I found other uses for it. And I printed all sorts of cool little knickknacks and gadgets that make my astrophotography life easier. So all sorts of special spacers and little gadgets and adapters, and like a fan enclosure for my Newtonian as a heater. Yeah, it's super useful for that. So as far as building the telescope, like actually 3D printing a whole telescope, I have a little concerns with like structural integrity of that, and just how well it's going to hold shape and collimation and things of that nature. But hey, if the technology gets advanced enough, and you're talking a corporation printing in metal, if you're looking at metal 3D printing, sure, I think that's a great idea. I know for a fact if I tried to print a telescope with my PLA printer that's in my living room, that'd be a big mistake.
Gotcha. Yeah. For something small for now, because I know I had a few Russian photographers who printed, Bakhtinov mask before with a
Oh,
3D. Yeah, you can do these things. I mean, with a 3D printer, but I'm pretty sure that is going to be taken to the mass producing, 3D printers, because of course we're talking about lowering the price, which I think, for me it sounds like a great idea, because the more people will look up into the universe, and the more people will get inspired, the more people will pursue hopefully their career in the space industry somewhere, someday. So it's very promising, because it seems like everybody's talking about, equipment is not being on the shelves, so somebody has to probably look up different angles of.
Yeah. So definitely, I mean, all those sorts of knickknacks and adapters. Like I said, I mean, I made the heater enclosure. I've made a flat panel. I've made Batinov masks, lens caps, star spike masks. I've made spacers, like little offset spacers. I've made camera caps, like little camera caps that can screw on, so I don't have to buy them. Right? I mean, it's like something that would just be $5 or $10 online, but I can print for 50 cents right here at home and have it today. Right? Yeah. Those kind of things are amazing. When it comes to mass production is a little bit harder of a question, because 3D printing has the same cost for every item you print. It's a flat cost. Whereas if you think of something like injection molding, so like let's take a Batinov mask, for example, right? How they make a Batinov mask, I don't really know, but if it's like an injection mold process, or kind of like a stamping process where you just take a sheet of plastic and you stamp it out, right? That has a one-time cost, and then that's amortized across the number of Batinov masks you make. So 3D printing is really, unfortunately, not the solution to mass production that a lot of people would hope it is. But it is a good solution to prototyping and rapid development of things. So, if you need a Batinov mask at home and they're all sold out, print one, right? If you need a telescope and they're all sold out, I don't know if I could say print that. I would not print my own telescope, yeah.
Got it. At least not for now. Okay.
Not for now.
Not for now. Got it. So can you tell me what's in the bag for you personally? I mean, what do you have in a pipeline in the near future when it comes to shooting the objects more nebulous? Like, what are you planning to take on? And maybe talk about your own personal equipment. Do you have anything in line, just like building home observatory? Is that in plan as well? Where do you want to take it, your equipment? How far?
Yeah, those are good questions. So what I'm currently imaging, I'm proud of myself. This is the first time I have dedicated multiple days to shooting a galaxy since the year I started the hobby. Like I said, I'm a nebula guy, I'm not a galaxy guy. But I'm currently shooting M81, M82, so kind of a classic classic galaxy to shoot. Hoping to get a little IFN in there, integrated flux nebula. So that's my way of filling the frame, right? Is turning this small dot in the black sky into a filled frame. Is hopefully I can get the IFN. Hopefully I live these words down when I don't get the IFN, but we'll see. Maybe with enough time I'll get there. Currently got something like, I think 8 or 9 hours exposure time. Some of that's HA for the galaxies themselves, and then I've got all my color data. And then I'm going to try to. Do I have all my color data? I think I need a little bit more. Yeah. Need a little more color data, and then I'm going to try to dedicate at least 2 nights of dedicated luminance. So hopefully about 16 hours luminance. Somewhere around 24, 30 hours of total integration time. And Bortle 4 might bring out the IFN. We'll see. People who are familiar with shooting this galaxy are probably sitting here like, oh God, no, that's not it. That's not enough. We'll see. Yeah, and then this summer, looking to pick up some more nebula, of course. I want to reshoot the Eagle Nebula. That's always a fun one. Super popular, of course, because the Hubble image of the pillars. But it's one I haven't shot since 2018, which was before I got my Sim 60, so I didn't really have a high quality mount at the time. So this will be my first real attempt at that. And then hopefully actually getting some more time on my Crescent Nebula. I was really happy with how the AI did on it when I upscaled it and denoised it, but I still would like to improve it a little bit more. So probably do that, capture some more stuff in the Cygnus area, and then this fall I've got a slew of different projects as well. As for my gear, what do I currently have? I have the Sim 60, which we've talked about a lot. I have a ZWO ASI 1600, the mono version. With a filter wheel. I've got the 3 nanometer Chroma HA-S203 filters and Chroma LRGB filters. Unfortunately, those are just 31 millimeters, and I've been thinking a lot lately about getting a larger sensor, which sucks because I need to upgrade those as well. But yeah, and then telescopes. I've got the Esprit 100 refractor, and I've got a Skywatcher Quattro 8-inch. Both are awesome telescopes. I can't say enough how much I love the refractor. It just works. It's simple. It's easy, and it is perfectly sharp. The Newtonian was super affordable, but you have to have some patience with collimation, and that's what I'm going through right now. So yeah. As for the future of my gear, yeah, I definitely smiled when you said a observatory, because there was a point right before COVID where I was thinking about buying one. I was living in Denver at the time, and I live in Boston. I was living in Denver at the time, and I was looking at property actually to buy property for an observatory, and actually setting up the infrastructure for it and building it. I had plans together for the observatory itself, and then as life goes, I got a job out here working with Commonwealth Fusion Systems, the fusion company I work for, and so I kind of shelved that idea for a while, but definitely hopes in the future to get to that point. I'd love to have an observatory. I'd love to have an awesome sensor, awesome telescope, and it kind of shoots and does its thing. But I'd also want one that I could carry and travel with, right? Like the fun of astrophotography for me is getting out and capturing the data. I hate processing. I don't love the processing, workflow thing. I like getting out under the skies, seeing the stars, playing with the telescope, getting the data, and just seeing that first shitty black and white grainy image show up on my laptop screen. I'm like, that's amazing. Doesn't matter how bad it looks. I'm like, that's amazing. Look at all that structure. And then the processing is that's the homework, right? To me, that's the boring part, but that is where you make the magic happen, really, with the structure of the data, the color. Yeah.
Got you. Okay, that's great. So hopefully, again, fingers crossed for you for the observatory, because that's a really cool thing to have. I don't think that a lot of people can brag about it, because a lot of people don't have it. Telescope is as far as some people want to go, which again, buying a land, as I said, building an infrastructure and having a telescope, probably upgrading equipment. It sounds like, of course, it's money, but it's time, it's effort, and it's dedication. It just shows that you're really dedicated to this industry, and it's not like you're gonna be here for a while, for a few months, so that's really cool. I love that part. So on that note, again, as you're talking about having headaches, and again, it's tough to do the post-processing editing, takes a lot of time. You go back to the same images, re-edit them, and it's a big part. Like, I remember I talked with this guy. Again, there's an episode available. He lives in Australia, and he has his own observatory built out. And it's a 15-inch Newtonian telescope that he has. No, it's 22-inch Newtonian telescope that he has. And he does a lot of the observations. He doesn't do any of the astrophotography. All he does is observations. and he's right now a second or a third for variable star observation on the planet in the world, and he has, I think, 350,000 observations so far. So, and his name is Rod Stubbings. He's really cool, man. You know, and the amount of work, and I'll go back to my question here in a second, but he did so much for the community, for the, you know, for the space community, for the astrophysicists, for the astronomy, so much different papers that he's been featured on because of what he does. So do you believe that, again, astrophotography is great, but you're talking about the headaches and, you know, post-processing. So do you believe in the future, as we get more and more, you know, astrophotographers, do you believe that it should be more people going through, you know, observations too, instead of going astrophotography route?
Uh, that's another one of those philosophical questions. I think like I think there will natively be more people making scientific observations as well, because there's a divide, not a divide, there's a spectrum of people that join the astrophotography community, and they do so for different reasons, you know, honestly, the astronomy community, right? Some people join to look at galaxies and nebulae with their eyeball. Some people join to make pretty pictures. Some people join for scientific reasons. So if you get more and more people interested in space by taking these cool pictures, posting them online, showing them to people, then you're going to also capture those people that aren't interested in taking the pictures, but look at a picture and are like, "Well, look at those stars. I want to know more about the dots in the picture," right? You know, and then that person will then join, and then they'll get a telescope, and you know, they'll find out, hey, I can see these stars. I can also measure these stars. I can do this or that with personal gear. I mean, that was my moment for photography, was when I realized that it's amateur gear. When you Google Orion Nebula, or when you Google Andromeda, chances are 99% of the pictures that Google shows are amateur pictures. They're not from Hubble. They're not from some giant, you know, science telescope. So it's kind of empowering the amateur scientist as well as it is empowering the amateur photographer to do this kind of stuff. Do I think it's necessary? I think, you know, people should pursue what they're interested in, for sure. You know, there's no governing body in astrophotography that's going to say you must do science with your photos, right? You know, that's not the case. I don't do science with my photos. I just like to make pretty pictures. That's all.
It's still science, I think. It's
Yeah.
still, you know, it's not far end of the science. It's not like, you know, but look, as you said, you know, you're adding tremendous value to the community, because it is a community. And so you brought up a great point. It doesn't matter which angle you're going to take. Is it only observations or astrophotography? You're still going to be adding value to a lot of people and encouraging other people to pursue either astrophotography or just, you know, just to get their curiosity going again. Because I do believe, like, including myself, a lot of people lose it somewhere, you know, because if you ask a kid, you know, a 7-year-old kid, what do you want to be, before the educational system mess them up, they will say, look, I want to be an astronaut or something like that. The astronaut is going to be there for sure. But
Oh,
then, of course, you go through the educational system. Again, everybody has a different choice. And you get installed. Okay, there's priorities in life. You have to have a job, pursue the career, do this, do that. And you kind of think about the space, and, you know, just like it's secondary or not even important thing anymore. And a lot of people forget about it. You know, they forget we're living on this ball collectively, and there's all this space around us that expands faster than the speed of light while we're talking now. So, you know, it's a beautiful thing. And I think you being part of that community, and again, looking at the posts, 700,000 likes, you're not going to get all the emails saying, oh my God, Trey, you inspired me, now I will pursue this. But I'm pretty sure there's a lot of people who got into something because of your photographies, you know, so it's really cool.
if I can convince one person to get into the hobby, that's all I need. Like that's plenty enough for me. One thing I want to say,
Sure.
you mentioned how everybody adds value. It made me think, you know, when we have like the big star parties, right? It was always so cool because you would go to different people's setups, right? And everybody did have a little piece of value they'd add. You know, there'd be the guy out there that had like a huge, you know, 20-inch Dob, and he'd be like, come climb this ladder, look through my telescope. And I'd be like, sure, that's cool. Like, let's do it. And then you'd have the guy in the corner with like 12 screens set up and then graphs and measurements going on. So it, you know, it really is, it's interesting how everybody add something unique and exciting to the hobby.
Exactly. Indeed. Gotcha. Okay. So got a last question here for you. So again, just want to say, big thank you again for coming over today and sharing all the continue to share and inspire people today on this episode. It's really cool to have people just like you who are, not even, I do admire people who do astrophotography. Those people are really cool. I had a bunch of those. I'm looking forward to having more. Again, you're one of those people who are, into astrophotography. You're part of the community, but you're also part of the science field again with what you do full time. So this is really cool because I do think like people who are in the science field, maybe sometimes they get okay, that's kind of a job, and after that you probably go to the bar or you watch a game or something, for the free time, for the spare time. But for the spare time, you choose to do the astrophotography and still to be involved in a science kind of part. So this is really cool. So part of that, what you're going through right now, and continue to innovate yourself and continue to be better and to find the different angles, how you can improve. Like, I'm just wondering, like, is there something that you're set your mind to when it comes to leaving your own personal like footprint or legacy behind you also?
Yeah. Um, so I mean, before I ever went into college, when I was in high school and I was trying to decide what I wanted to do, I guess like the simplest mantra or simplest, goal I could make for myself was just wanted to do something that would change the world. And so that's what pushed me towards space. Was I felt like space was the way that we could get there, and we could make the world a better place, or we could have a lasting impact on the world or the direction of humanity. And so that was what I, worked toward at SpaceX, in the pursuit of getting to Mars, making humanity a multiplanetary species, bringing internet to everyone on the planet, right? So that's kind of, a great step in the direction of what I was hoping to do with life. And now the next step of that is, how do we address global warming? How do we address the upcoming energy crisis as underdeveloped countries become more and more developed and their energy demands grow? How are we going to produce that energy? And so, yeah, I mean, that's kind of the simplest goal I could give myself is I wanted to do something big that would impact a lot of people or impact humanity as a whole. And of course, I won't do that alone. Like no engineer does that alone. It's the work of us all, pitching in and doing what we can to do it as a collective. So yeah, I guess that's my hope for a lasting impact, and we'll see if I get there.
I'm pretty sure. I'm pretty sure because again, just looking at your dedication when it comes to okay, I'm gonna build an observatory. Yeah, I'm pretty sure you're gonna get through all the stuff because you're into this long term, right? You're not living this as a well, at least I'm thinking, and what I'm seeing so far is what I'm getting from this 1.5 interview is this is who you are, and you just live it instead of having like a job. And that's what I told you a lot about you. Instead of having a job and then you come back from a job and you do whatever, you live your life and you go to the you still do this thing still. So it seems like you're living this life, which is really cool because we need so many more people just like you who are building this industry and taking part in this industry. So because again we talked about kind of the time frames, as this NASA engineers talked about, this is not being invented yet, and that's why it takes so long. So I think the more people just like you we're going to have in the industry, the time frames are going to become shorter and shorter. So it's very promising when I see people just like you. So it's really cool.
Thanks.
So, okay, guys and girls, I hope you enjoyed this episode as much as I did. I mean, it's awesome. Trey is a great human being. I give him a lot of compliments, until now. So, make sure to get in contact with this man. He has a great Instagram. Again, not a lot of posts so far, but we're gonna see probably more in the near future. Again, as you mentioned, he's gonna go with Nico. Nico has been on the podcast, so I'm pretty sure you're gonna do some cool shooting as well. Get connected with this man, ask him questions about the equipment because we didn't cover a bunch because there's the astrophotography is quite a steep learning curve. And it's probably going to be 4 hours for us to kind of learn everything there, and just get in contact, ask him questions about this or about physics. There's a lot of great topics that we covered today. And of course, if you pass this episode to your friend, that's always valuable and great as well. And no, because I do not need more subscribers. I do need more people to get involved in the science community, astrophotography. And by you sharing this message with your friends, I think it will, impact them in a great way and help them to open their personal mind and eyes for what's happening in the industry and pursue something. So again, Trey, I appreciate you coming on today. Great pleasure to finally meet you after all this time. So looking forward to connect with you sometime in the future again. And as always, guys and girls, I'll see you next time. And until then, don't forget to keep exploring.